Hello guys, welcome. Today we'll introduce you to the concept of acids and bases. Acids and bases are very much integral part of our lives and we cannot conceive of life without these two. So let's take a look at the various theories which have evolved over a period of time and that will give us more insight into the nature of these two substances. So if one is being asked what essentially is an acid, so, no matter whatever theory has evolved or will evolve in the future, one thing is never going to change, which is the fact that every acid is essentially an electron hungry beast. Every acid is essentially an electron hungry beast. An electron hungry beast. So, what it essentially means that acids basically seek electrons from other parties, and this they can do either directly or indirectly, and we'll see shortly. This leads to various classes of acids. Alright, so without further ado, let's look at the main theories which have evolved over the period of time. And as far as base is concerned, base is a generous electron donor. A generous electron donor. Now, one of the earliest theories which were put forward to explain acids and bases was given by the Swedish chemist Arrhenius. And it's a very simple theory. According to this theory, an acid is an H plus ion donor, while a base is a hydroxide ion donor in aqueous medium. So in aqueous medium. So as we see, this particular theory is restricted to using water as a medium, even though it's very simple and it works very well for simple acids and especially those acids which are very commonly encountered during those times. So for example, if we talk about hydrochloric acid, then this theory neatly explains why base is an acid, because essentially it furnishes the H plus ions, while a traditional base like sodium hydroxide, so this furnishes the hydroxide ions. So as far as the traditional acids and bases are concerned, this theory works pretty well, so no issues. So as we see hydrochloric acid, why it is an acid, it neatly explains. So acids are H plus ion donors, while bases are OH minus donors. So this is behaving as an acid, ये acid की तरह behave कर रहा है, while this correspondingly is behaving as a base. So very simple, elegant theory, but then it has very limited scope. So one particular reason is that this is restricted to using water as a medium, and then there are several reactions between acids and bases which are simply beyond the scope of Arrhenius theory. So let's discuss that as well. Where does it have its limits? Its limits. So here we go. So let's say we have a reaction wherein HCl reacts directly with ammonia. So both of these are gases. So let these gases interact and we get the salt ammonium chloride. So neat and clean reaction between these two, HCl and ammonia forming ammonium chloride, right? But over here you will see that there is no role of OH minus. There is no oxygen in fact anywhere in this reaction. यहाँ पे कहीं oxygen है नहीं, so there is no question of any hydroxide ion coming into the picture. So that means this is a limitation. This particular theory cannot explain the reaction in the gaseous phase between HCl and ammonia. So it's simply beyond its scope. Similarly, if we take the reaction between BF3 and ammonia, BF3 and ammonia के बीच में, again we get a salt over here. So we obtain BF3 minus NH3 plus. So this is a solid, it's a salt. But again we see the same issue that there is no OH minus involved, and in fact there is not even H plus involved here. There is no transfer of H plus. H plus does not move out. So therefore Arrhenius theory, it's very limited in scope due to the restriction of medium, and also due to the fact that there are several reactions which simply do not involve either the H plus or the OH minus or either of these two. Right? So these ions will simply not be involved. So as a result, Bronsted and Lowry, they came up with a much broader concept. So they refined and redefined the theory put forward by Arrhenius. So what they said, let's take a look. So Bronsted and Lowry, So these guys basically said that acid is a proton donor. Acid is a proton donor, while base is simply a proton acceptor. So this theory is more elegant, as we see that it's very symmetrical. An acid is proton donor, while a base is proton acceptor. This theory is by Bronsted and Lowry. So Bronsted-Lowry theory, and according to this, acid is a proton donor, while base is a proton acceptor. So very symmetrical stuff, and we see that it can immediately explain the reaction which we just discussed. So where we have NH3 plus HCl reacting directly, so we get ammonium chloride. This particular reaction can be neatly explained by this fellow. So what is happening essentially is that HCl is transferring the proton to NH3. So NH3 transforms into essentially NH4 plus, as you see the parts over here, and Cl minus is the other counterpart. So it involves a simple transfer of proton. Even in the gaseous phase, this proton transfer is happening, no issues, and we get this salt over here on the right hand side. So this reaction is easily taken care of, right? The theme is, as I said initially also, that every acid's actual motivation is to gain electron density. So it tends to acquire the electron density. Whatever be the theory, the essence of acid will never change, and this is what we observe here. So HCl is basically gaining the electron density. It is gaining the electron density. It's making nitrogen over here, which was delta minus, electron deficient, and it itself becomes electron rich. It itself acquires the electron density. Similarly, let's take about typical acid-base reaction. If we allow calcium oxide and sulfuric acid to react with each other, we get calcium sulfate and water is the byproduct. So the idea is this. This is an ionic substance, so you have Ca2 plus and O2 minus, and what is happening is that sulfuric acid is transferring two protons to oxide ion, and this transforms the oxide ion into H2. So over here we see that oxygen was carrying two full-fledged two negative charges, but over here it is carrying only delta negative charge, and here this is an ionic compound Ca2 plus and sulfate 2 minus. So essentially sulfuric acid ends up indirectly taking the electron density from oxygen. So oxygen was carrying the two negative, but now sulfate carries the two negative charge. So it's an indirect way of taking the electron density. So this is what Bronsted, acids and bases are. So essentially, it's an exchange of electron density only, but indirectly. It's not a direct route. It's an indirect route. So the acid has indirectly accepted the electron density. Indirectly accepts electron density. And this is happening via protons. So protons basically do the job. So it's kind of, the acid is sending associates to get the job done. So H plus ions are the associates here. They basically attack the oxide ion and make it less electron rich, while sulfate requires more electron density. So it's an indirect way of gaining the electron density. So this is a very elegant theory. There is no doubt about that. But then, it also has certain, cases. There are certain cases where even this theory fails to explain certain reactions, and one such prominent case is the reaction between BF3 and NH3. So if we look at this reaction between BF3 and NH3 and NH3 to give rise to this adduct, so we get this adduct here. So let's take a look at this. So BF3 negative and NH3 positive. So we get this compound. This is salt, and this salt is known as adduct. So the reaction essentially involves, the nitrogen over here forming a coordinate bond with boron over here, right? So ammonia is a well-known base, and this is a salt. This is essentially a salt. That means this must be behaving as an acid. So this substance has to be an acid. But then we have a problem. We have a conflict with the Bronsted-Lowry concept, because if it was an acid, according to Bronsted theory, an acid is supposed to donate a proton, but then there is no hydrogen atom over here. So there is no question of any proton coming. There is absolutely no hydrogen atom in BF3, so there is no question of any proton transfer over here. So this theory falls short to explain this particular reaction. That is why we have the next theory, which is broader than the Bronsted-Lowry concept, and this is known as the Lewis theory. इसको Lewis theory बोला जाता है. So Lewis theory. So according to this theory, well, an acid is simply lone pair acceptor. It's a lone pair acceptor. It's a lone pair acceptor, while a base is simply a lone pair donor. A lone pair donor. So an acid is simply a lone pair acceptor. An acid is simply a lone pair acceptor, while a base is a lone pair donor. Right. So let's see how it elegantly explains this reaction. So the reaction which was beyond the scope of Bronsted-Lowry, now that could be very well explained using this Lewis theory concept. So now it becomes very easy to understand that why this is behaving, or how this is behaving as an acid and how this is behaving as a base. Well, it's simply the case that the nitrogen over here, it is transferring the electron density to boron, making the boron complete its socket. So we get this compound, right, where boron bears the negative charge and nitrogen is bearing the positive charge now. So as we see now, this particular reaction comes neatly under the scope of Lewis theory. It could not be explained by the Bronsted-Lowry concept. So this is the case over here. And it's not the case that Lewis theory is perfect. Okay, the problem with the Lewis theory is that this is just too broad. So it includes, many reactions within its scope which are traditionally not to be included. For example, the reactions in coordination compounds, those are usually not considered acid-base reactions, even though Lewis theory would try to include them in its scope as well. So this was a brief introduction to the concept of acids and bases. So let me summarize what we have learned essentially. So in this session we have covered the acids part. In the next session I'll be covering the base part. So we have gone through three theories on acids and bases: Arrhenius theory, the Bronsted-Lowry theory, and the Lewis theory, right? And we have seen that whatever be the theory, the essence of acid is always the same, which is the fact that an acid is an electron-hungry beast. It always wants to take electron density, while bases are generous electron donors. All right. Now, the classification basically more or less depends on whether the electron transfer happens directly or indirectly. So we looked at the Arrhenius concept, right? That has its scope only in the aqueous medium, so very narrow, restricted definition. Bronsted-Lowry concept, very elegant, very symmetrical, all right? And there we saw that electron density transfer is accomplished through the exchange of proton. It is proton which leads to the exchange of electron density. And the Lewis theory is very broad, extremely broad in its scope, and it easily explains those reactions, those acid-base reactions which are beyond the scope of Bronsted-Lowry concept. But then its own broad range kind of in a way is slight drawback too. But we'll talk more about that in the next session. For the time being, it's time to call it a day. We'll see you again. Thank you.